Okay, so we looked at those composite figures. We combined the circles and everything. Our next step is to move into 3 dimensions. So let's go back to our definitions in geometry. We started out again with that simplest figure, the point. We created a length by moving it in a single direction. The length was equal to the distance. Then we took that segment and we pulled it in a second direction. And if we measured that distance that we pulled it perpendicular, we created an area. Now if we latch onto that and we pull it in a third direction, also perpendicular, to the original, we now create a solid figure or a volume. Think about this. At first we had the point, we moved a single direction, we now had 1 dimension, right? So all of our lengths were just standard units, inches, feet, centimeters, whatever. When we had an area, we had pulled it in 2 directions, we now had 2 dimensions. So all of our units were squared, inches squared, feet squared, centimeters squared. The 2 signifies that it's 2 dimensions. Well, now we have, we've taken that 2 directions, we've pulled it in a third direction. So now we have moved in 3 directions. We now have 3 dimensions. What do you think our units are going to look like? Inches to the third, inches cubed. Feet to the third, or feet cubed. Centimeters to the third, meters to the third, or meters cubed, and so on. The size of that solid object, of that volume, depends on the size of the original 2-dimensional shape. That size was described by an area. Now that shape is called the base of our solid object. It's called the base not because it's on bottom. We're used to the base being the bottom of something, but it's not because it's on bottom. It's because that's what this object is based off of. That is the shape that we grabbed onto and pulled to create the volume, to create the solid. So that is the area of a base. And how far we pulled it. In other words, the height. So the volume of a solid object is equal to the area of the base. Notice I put the base in just little letters after the area. Times a height or a distance. Now I usually just call it a distance because it's not always up and down for height. We're going to stick with somewhat simple shapes here, so we're not going to get too carried away with them, but it's not always a height. So let's take a look at some examples of finding area. How many of you are struggling to draw the 3-dimension? I'm going to show you a little trick. Draw a rectangle like that. Then move from this corner, move up a ways. Do the same from this corner, same from this corner, and this corner. Basically, you're drawing a second rectangle. It's the same size, just shifted up and over. And connect the corners. So let's say that this is 14 inches and 6 inches and 10 inches. Since this is a box, any side of this, any area of this could be considered the base. So we're going to use the bottom as the base. What is the area of the base? 14 inches by 6 inches, right? Which is going to be 84 inches squared. Remember, area is 2 dimensions multiplied by each other. So that means our volume is the area of that base, 84 inches squared, times that height of 10 inches. Or 840 inches squared times inches is inches to the third. Now, many of you have seen volume defined by this: length times width times height. Well, what we did here, the length times width is just the area of the base, right? So why didn't I just say length times width times height? Well, because if I do that, we have to have a separate formula for every type of solid shape we have. Because at some point, and you know I'm going to do it to you, in fact, probably like right now, you might run into something like this. Length times width times height doesn't work here, does it? But we can do area of a base times height. First of all, the base of this is not the bottom. It is this triangle. Why is that triangle the base? Because that triangle is the shape that it is based off of. If I take that triangle, I can grab onto it and I can actually slide it through the whole object like that. See what I mean? Does that make sense? In other words, if I were to take this and cut this somewhere, that triangle is the shape that it's going to look like where I cut it. So to find the area of the base, the capital A with the little b means area of base. Well, this is a triangle, so the area of that base is 5 feet by 12 feet divided by 2, which is going to be 30 feet squared. So now my volume is the area of the base, 30 feet squared, times that distance. It's not really a height this time, of 20 feet. Well, 30 times 20 is 600. Feet squared times feet is feet cubed. 600 cubic feet. Make sense? It's a triangle. That right there. That's not quite so bad, yeah. This next one might be a little tricky to draw. There you got it, cylinder. So I have a cylinder. Well, once again, what's the base of this? Well, it's the circle with a diameter of 10, right? That shape there is the base of this, because that shape is what I would grab onto and I could slide through the whole thing. Does everybody see how I determine what the base is? That's kind of the base that's, if they're pushing Play-Doh, ever you see with little Play-Doh makers where you push the Play-Doh through? That would be the shape of the hole that you're pushing the Play-Doh through that makes the thing, right? That's your base. So we need to find the volume here, we need to find the area of the base. Well, the base is a circle. So its area is pi times radius squared. Where's the 5 come from? Half of the 10. So pi, that's 78.5, correct? And that is in inches, this is inches squared. So now my volume is simply the area of that base times the height. Oops, that's inches, not inches squared. Which is going to give us what? 1,570 inches cubed. So by defining the volume as the area of a base times a distance, I've eliminated the need to have a separate formula for every type of shape. Otherwise, we would have to have a different formula for the triangles that we did up here, and we'd have to have a different formula for the cylinders that we just did here. All of them are the same concept, the area of a base times the height. In fact, I can have really ugly shapes. Please don't. It's like a mailbox stood on end. You're correct. So let's say that this is 30 centimeters, 40 centimeters, 50 centimeters, and let's go 16 centimeters here. Oh, that can't be 16 centimeters. That has to be 15. So it's got to be half of the 30. To find that volume, I first find the area of the base. Now the base of this, it can be the top or the bottom. It's that rectangle and the half circle, right? So the rectangle is 30 centimeters by 50 centimeters, correct? So that's 1,500 centimeters squared. The half circle is pi times 15 squared, because the radius is 15, half of the 30. I also gave it to you down here. So pi times 225 is 706.5, you see? You got it, 706.5 centimeters squared. So that means the area of our base here is 2206.5 centimeters squared. So my volume is just that times my 40 centimeters of height, which is what? 88,260 centimeters cubed. That's my volume. What do you think? A lot easier than trying to get a separate formula for everyone?
Anything for my therapy. This makes sense.
In your notes, try to find the volume of that. Oops, stay there. So for area of the base, what two numbers do we multiply? This is 8 here, and this is 15. Those make the right angle of the triangle. So 15 times 8 divided by 2 is 60 inches squared. So that's the area of my base. My volume then is the 60 inches squared times 10 inches of height, 600 inches cubed. How many of you had 600 cubic inches? Okay. Any questions on that? Does it make sense once you see me do it, at least? Okay. The starting point is tough, and I realize once you get home, you're not going to have me there giving you little pushes. It's going to be tough. The 17 is the hypotenuse, because basically what you have is this triangle.
If we limit
So when you're dealing the area of this triangle, you have to take the two sides that are the two legs. Okay. Let's try another one? Okay.
One more, please.
Sure.
Circle. Cylinder.
Maybe we can do the speed and the cones and the pyramid. That's coming Thursday.
Find the volume of that. That's coming Thursday. So, what's in my base here? The base, of course, is this circle with a diameter of 8 feet. So the area of the base is going to be pi times 4 squared, otherwise known as 50.24 square feet. So the volume is the area of the base, 50.24 square feet, times 10 feet of length, or 502.4 cubic feet. Well, because you didn't have to identify which two sides to use for the area. It's in the back cover of the book. There are formulas for these on the back cover of the book if you don't want to go through the area of the base times the height. That's the back cover of the book.
It's got all of your, a lot of them anyways.
Yeah, it's $16. Yeah, it's just so
Oh my God. I would have tried to cost the very almost
Yeah.
Yeah, it's like $90 some just for my math lab.
I rented the book.
How about this? Find the volume of a pyramid. Now, when we did our triangles, we were doing area. What we did was we said it's a full rectangle and just divide it by 2. So for a pyramid, could I find the area of a box and divide it by 2? Not necessarily, no. Because if I look at this, if I cut this in half, do I get a pyramid? No, I cut it across here. What I get is a wedge. That's not a pyramid, it's a wedge. To get it into a pyramid, I'd actually have to cut it a second direction like that. Now it's a pyramid. But what I cut off the second time wasn't half of what's there because I cut off the thin part on top. So it's more than a fourth. What's left is more than a fourth. Well, to find out what it really is, what portion it really is, would take calculus to divide that. So I'm just going to ask you to trust me on this. That the volume of the pyramid is the area of the base times the height, just like a box, but divided by 3. It's 1/3 of that volume. Now here's the way I remember that. For the area of a triangle, it's base times height divided by 2. How many dimensions is a triangle? 2. Divided by 2. A pyramid is how many dimensions? 3. And volume is 3-dimensional. I'm dividing by 3. So for this volume, I'm going to find the area of the base, which is what? 16 inches by 16 inches, or 256 inches squared. And then, for the volume, it'll be 256 inches squared times a height of 20 inches divided by 3, which will give us 1706.67 inches cubed. In your notes, find the volume of that pyramid. base 12 by 12 and a height of 15. Okay, so the area of our base, it's 12 by 12, so it's 144 inches squared. So then the volume is going to be that area of the base, the 144 inches squared times 15 inches divided by 3, which will give us 720 inches cubed. That is supposed to be round on bottom. It's a cone. I want you just to see what you come up with for the volume of that. Let's see if you can make it work. Okay, it sounds like you guys are catching on. This has to be the same thing. The area of the base, it's a circle now, so it's 3.14 times 4 squared, otherwise known as 50.24 inches squared. But then the volume is going to be the 50.24 inches squared times 10 inches divided by 3, otherwise known as 167.466 or 167.47 inches cubed. Not bad at all.
Try that now with a 2 instead of the 8 and a 4 instead of the 10.
Okay.
I don't care. I spent forever on this one last time.
So this is 2 inches and this is 4
because
inches.
there's a 1. So 1 squared is 1, correct?
So the area of my base is 3.14 times 1 squared, or 3.14. That's inches squared. So my volume is 3.14 inches squared times 4 inches divided by 3. 4 point what? 19. Okay. Let's talk briefly about something called surface area. A surface area is the amount of area it takes to cover the surface of something. What's that? Surface area? Well, you'll learn something new. So let's go back to that box that we had. And let's say it's 12 inches by 6 inches by 10 inches. If I wanted to find the surface area, I could find the area of each of the rectangles and add them together. There's the rectangle on bottom is 12 by 6. And of course there's one on top that's the same size. The rectangle on this end is 6 by 10, and there's one on the other end that's the same size. And then the one on the front is 12 by 10, and there's one on the back that's the same size. But rather than having to find 6 different rectangles or 3 rectangles and double it, it'd be nice to be able to find this in one single step. And also the fact that once we get to like cylinders, there aren't any rectangles on the sides to find. So I'm going to use the box here to define a way, just like we did with the volume being the area times the height, define a universal way of finding surface area. Surface area, abbreviated SA, can be divided into the area of the bases plus something called lateral surface area or lateral area. Lateral area, and I probably spelled that wrong. Lateral area is the area that connects the bases, the area between the bases, in other words. So the base is here. This would be the base on bottom. And of course, the top is identical to it. So those are the bases. The lateral area is the area of all these sides that wrap around. The front, the end, the back, and the other end. To find that area, what I can do, think of it like finding the area of the walls of the room. You could find each wall separately, or you could cut this corner and fold all the walls out. The height is still going to be 10 inches here. But the length, well, I'd have 12 inches, and then 6 inches, and another 12 inches, and another 6 inches, right? 12, 6, 12, and 6. Does that make sense? Puts all those rectangles together in one big long rectangle. So this length here, if I add all those up, is 36 inches. That length right there, 36 inches, is also the perimeter of the base, the distance around that base. The area of this rectangle right here, my lateral area, is the perimeter of the base times the height. So the perimeter of that base was 36. I can't write today. 36 inches times the 10 inches of height. So 360 square inches is the lateral area. So finding the surface area of this, all I have left is to find the area of my bases. Well, the area of my base is 12 inches by 6 inches, otherwise known as 72 inches squared. So the surface area here is 72 plus 72. Why did I do that twice? Bottom and top, you got it. Plus 360, otherwise known as 504 inches squared. That is my surface area. Why on earth do I define surface area that way by dividing up into area of the bases and the lateral area? Same reason I did the volume that way. Not because I'm mean and I want to see you suffer. That's just a byproduct. But when we have a cylinder like this, of course, the area of the base is going to be pi times the radius squared. So pi times 4 squared is still 50.24 inches squared. That's the area of the base. And there's another one of those, right? The bottom and the top, right? The lateral area requires that I have the perimeter of the base. Well, the base of this is a circle. The perimeter of the base is a circumference. How do I find circumference? Pi times diameter. 3.14 times 8 inches is 25.12 inches. So my lateral area is the perimeter of the base, 25.12 inches, times the height of 10 inches, or 251.2 inches squared. So this adds up to 351.68 inches squared is my total surface area. What do you think?
Okay.
Good stuff?
Yeah. On the rectangle, the lovely book defines it as 2 times the length times width plus the 2 times length height plus 2 times width and height. What would it be equivalent wise for writing this down to know for, say, your cylinder?
For the cylinder?
Yeah.
2 times pi r squared plus 2 pi r h.
That makes it much easier
Why are we
to know those little step things make so much easier.
Why am I not doing those formulas? Because this one has no formula.
Okay, but some of them do, so
Yeah.
it makes it a little less stressful.
Yeah. And if you want to memorize the formula for those special ones, that's fine. I don't like memorizing formulas. If you know the concept, you can come up with the formula, or you can find the formula. But to find the surface area of this, I have to have the area of the base. What is my base? The triangle that is 5 by 12. So 5 times 12 over 2 is going to give me 30 feet squared. And of course, there's one on the other end. Now for my lateral area, I need the perimeter of the base. So the perimeter of the base is going to be 5 plus 12 plus, I need to know that side, don't I? How do I find that side? You got it, 5 squared plus 12 squared equals c squared. If you do that out, you're going to come up with 13. So we add those up, we're going to get 30 feet is the perimeter of the base. So my lateral area is 30 feet times 20 feet, or 600 square feet. So adding up 30, 30, and 600 gives me 660 square feet is my total surface area. And like I said, if you want to memorize the formulas, that's fine. If you have one concept that covers everything, that's the way I like to do things. Well, you've almost suffered enough. That, of course, is very good, a sphere. And my artwork doesn't suck as bad as I thought it did. For a sphere, to find the volume and the surface area of a sphere, we could derive those formulas, but once again, it would take some pretty complex calculus. I don't have the 2 semesters required to get you to the point where you do the calculus. So this is another point, and I hate doing this, but another point where I'm going to give you a formula and just ask you to trust me. So the volume of the only defining characteristic of a sphere, by the way, is its radius. There are no other dimensions to measure. Its radius is the only dimension. Well, diameter, I suppose. But so the volume of a sphere is 4/3 times pi times the radius cubed. 4/3 is a constant no matter what size the sphere is. The only thing that'll change here is the number you put in for the radius, for r. So let's say that we have a sphere with a radius of 6 inches. So that volume will be 4/3 times 3.14 times 6 cubed. So on your calculator, you do 4 divided by 3 times 3.14 times 6 to the power of 3. 904.32 inches cubed, because that is a volume. 904.32 inches cubed. Questions? The surface area is defined by the formula 4 times pi times the radius squared. So for this object, that surface area is going to be 4 times 3.14 times 6 squared, or 452.16 inches squared. Correct? We do have time for you guys to try a sphere. So let's have you try a sphere. Pretend that looks like a sphere. So 12 centimeters is my radius. Find the volume and the surface area. So the volume would be 4/3 times 3.14 times 12 to the third power, which is 7,234.56. The other side is centimeters cubed. Does that look right? The surface area is what? 1,000. Oh, let me do the formula first. 4 times 3.14 times 12 squared, which is what? 1,808.64. Perfect. Any questions? How you feeling about tonight? Do you like the solids, the volumes, and surface areas and stuff? Okay, well, you have suffered enough. There is a new quiz due by tomorrow. That is Wednesday at 11:59 p.m. And there's a new homework due for Thursday's class. What's that? There will be a homework assignment that starts on Thursday and it'll be due like the Tuesday we come back. Yeah. So you'll have 12 days to do that one. Okay, I'll give you guys the last 6 minutes to get started on stuff if you want to. Otherwise, we'll see you on Thursday.